The mean, often called the average, is the sum of a set of numbers divided by the total count of numbers in the set. It's a measure of central tendency. On the other hand, variance measure how spread out the value in the dataset are from the mean. It's calculated by taking the average of the squared difference between each value and the mean of the dataset. In this practical, mean and variance for the leaf is going to be calculated to determine how the dependent and independent variables are related. There is three objectives from this practical. First is to calculate and describe the following descriptive statistic: mean, variance, and standard deviation. Second is to understand the concept of correlation. And the last one is to determine the relationship between two variables.
Here are the materials that we need.
For the methodology, first, 10 leaves were taken. Their length and width were measured and recorded. The mean, variance, and standard deviation of the length and width of the 10 leaves were calculated. The data was tabulated in a graph. Second, another 10 leaves were taken and repeated as the first step. This step repeated for another 3 sets of leaves. And then the results were tabulated as a data matrix. And last, all the 30 leaf data were used to plot a graph of leaf length versus width of leaf.
This is the result for set 1. This is the result for set 2. And this is the result for set 3.
Now for the discussion. All the data that has been collected in each set were used to find the mean, variance, and the standard deviation. Mean is normally used in order to find the middle of the data or to sum up the data by finding its tendency. We must find variance to see the dispersion of the bell shape to see whether it has the big dispersion or small. Standard deviation is important to see how close overall data is to the mean and not how good the data is. Now, we will look to the mean. If we look at set 1, the mean for the length is 11.15 cm, which is affected by the longest leaf, which is 13.5 cm. Mean for the width is 5.1 cm, and mean for the weight is 0.83 gram. Now, we're moving to the set 2. The mean for the length is 8.5 cm. For the width is 3.8 cm, which is affected by the widest leaf, 4.8 cm, and for the weight is 0.45 gram, which is affected by the heaviest leaf, 0.8 gram. Next, set 3. The mean for the length is 10.7 cm, which is affected by the longest leaf, 11.9 cm. For the width is 4.3, and for the weight is 0.66 gram. Okay, now we move to variance and standard deviation. Now we will look into variance in each set for the leaf length, leaf width, and leaf weight. In the set 1, the aftermath is 1.8 0.633 for the leaf length, 0.433 for the leaf width, and 0.02677 for the leaf width. While in the set 2, the calculation is 2.7006, 0.4956, and 0.0525 for each. As well for the set 3, the result is 0.5844 for the leaf length, 0.0181 for the leaf width, and 0.003373 for the leaf width. The set that has big dispersion for leaf length, width, and weight is set 2. Last but not least, the standard deviation. In the set 1, the aftermath is 1.3650, 0.07314, and 0.1633 for each. While in the set 2, the calculation is 1.634 for the leaf length, 0.7040 for the leaf width, and 0.2291 for the leaf weight. As well for the set 3, the result is 0.7645, 0.13454, and 0.058078 for each. All the standard deviation values are no greater than plus or minus 2 standard deviation. Okay, now we can see the graph. By creating the graph, we are able to create relationship between leaf length and leaf width. The relationship is directly proportional between each other, which means if leaf length increase, then the leaf width will increase.
In conclusion, from this experiment, we are able to calculate and describe descriptive statistics, which are mean, variance, and standard deviation of multiple species in each quadrant. From the calculation of this descriptive statistic, we are able to deduce the relation between dependent and independent variable. The variable in this practical follow the concept of correlation, which means the two variables are linearly related to each other. By that, both of the variables change their value together at constant rate.
Okay, for the first our post-lab question, which is discuss the difference or similarity of the mean of length between different set of leaf. Do the same for the mean of width. Okay, now we will look into this table. This table shows each mean of each set. For the length, set 1 have 11.15, set 2 8.5, and set 3 10.7. Meanwhile, for the width, set 1 have 5.1, 3.8 for set 2, and set 3 4.33. And for the weight, for set 1, 0.83, 0.446 for set 2, and 0.658 for set 3. So, after we look all the data of the mean, they all have the different measurement. For the length, set 1 has the highest mean, which is 11.15 cm, followed by set 3, and the lowest one is set 2, which is 8.5 cm. This happened since the leaves are from different species. Thus, it has a difference in their mean. The difference between set 1 and set 2 is 2.65, and between set 1 and set 3 is 0.45, while difference between set 2 and set 3 is 1.2 cm. Now, for the width, the set data that have the highest mean is set 1, followed by set 3, and the lowest is set 2, which is 3.8 cm. The difference between set 1 and set 2 is 1.3 cm. Between set 1 and set 3 is 0.7. Meanwhile, the difference between set 2 and set 3 is 0.53 cm. But all of these data have their similarity, which is both mean length and mean width have the same pattern, which is set 1 is bigger than set 3 and set 3 is bigger than set 2. The difference that can show here is data shows variance between sets.
Variance is used to see the dispersion of the data of the bell shape with its mean to see whether it has big dispersion or small. By referring to the leaf has different measurements of width and length, we can say that the data has been taken varies with each other. This happens because some of the factors that affect the growth of leaf itself. The first factor that affect the growth of the leaf is genetic. This happens because the instruction itself asks the student to pluck the leaf from different species. They can differentiate the species by using their eyes or any sense that can be used. Another factor that may affect the development on the leaf is the condition itself. According to the circumstances, the tree may gain enough of their essential that let them be on the up and up or vice versa. It's not only happening amongst tree but also between the leaf itself. As old leaf may grow first, they may have gained sufficient nutrients and mature compared to the newest. As we discussed just now, set 2 has a big number of variants, which shows the big dispersion between the data. This shows that the leaf length, width, and weight are varied. Standard deviation is used to see how close overall data is to the mean because high standard deviation indicate greater variability in the data, while a low standard deviation suggests that the data points are closer to the mean.
As questions, it is necessary to have different sets of measurement for the measurement of leaf width and length because, as a data observer, we rely on accuracy before performing the discussion in order to achieve a perfect experiment. Thus, different sets of measurement for the measurement of leaf width and length is needed since it provides the benefits to our experiment. First of all, the presentation of the material used. In this experiment, the object that we observe is a leaf that comes from the same tree in one set, but different tree as it across the sets. Different sets of measurements allow for a more comprehensive understanding of the variability in leaf dimensions. Variations in genetic makeup, environmental condition, or developmental stages can result in distinct traits being displayed by leaf from various plants or population. Second, accuracy in the data. People suggest that we need to take the reading at least 3 times for a particular material used since it helps to ensure the uncertainties didn't occur. Researchers can evaluate the measurement dependability and spot any anomalies for inequalities by contrasting measurements from several sets. Lastly, being able to create a relationship across the sets. We can investigate links between leaf width, length, and other variables within the hypothesis by using measurements from various sets. For instance, we might look into how genetic features, age of the plant, and environmental factors affect the size of leaf. Students can gain a better understanding of the elements impacting leaf morphology and function by examining different sets of measurements.